Assalamualaikum and good day. Today we're going to continue new chapter, which is chapter 5, analysis of arch. We're going to focus on two-pin arch and the course outcome. We are able to analyze our arch and cable. Previously we done cable. Now we're going to study arch to determine reaction and internal force for our arch. For the arch, we're going to have a parabolic arch. This formula for half parabolic. Also, we're going to touch on circular arch, and this is relation between vertical distance and angles. And for the parabolic arch, between vertical distance y and horizontal distance x. Previously, you studied determinate structure for arch in theory of structure. Now you're going to study indeterminate structure, which is two-pin arch. Therefore, you cannot solve it by using static equilibrium, but to analyze that, you can change one of the support from pin to roller. Then we make it as determinate structure. Then we're going to apply principle of superposition to analyze our indeterminate two-pin arch. Now let's see for the case 1 where this is symmetrical parabolic arch and 200 kN at the crown. So we have to determine horizontal force at pin A and B. From indeterminate, we're going to make it determinate. That means we're going to remove support B to roller. That means no more horizontal at B, no more HP. Now we're going to cut it into half, into left side and right side. So at any x distance of first part, this one, at any x distance, at any of horizontal x distance, there will be M1 as anti-clockwise, and also at any x distance from B will be M2 and it is anti-clockwise. Now let's calculate for value of M1 and M2. So for left side, we take summation of M1 equal to 0 and positive clockwise. Since M1 is anti-clockwise, so negative M1. And we know we have force of 200 at the middle, so 100 on support A and 100 of vertical reaction to support B. So 100 times by x at any x distance. Here, at any x distance from support A, so 100 times x equal to 0. So we get our M1. M1 equal to 100x. M1 equal to 100x. So now let's see right side for M2. So we take summation M2 equal to 0, positive clockwise. So M2 is clockwise, so positive, minus 100 times at x distance from B equal to 0. So M2 equal to 100x. Therefore, M1 equal to M2 equal to 100x. So once again, once we remove support from pin to roller at B, we got no more horizontal force. From this relationship between vertical distance y and horizontal distance x for parabolic arch. For our case, we know our L is 18 meter and height is 4 meter. So let's substitute L and H into this equation. X minus X divide 18 square. So we get this is Y into X. Then we know horizontal direction formula is we have to integrate my divided by ei ds divided by integration of y square divided ei ds. From here, we simply can cancel out ei. Alright, sorry, this is not ds, this is dx. X distance. X. So this one my dx divided by integration y square dx. So this for h. We know our y here. So we can find what is integration my and integration of y square. So let's do one by one. Let's find value for integration of my dx from a distance of 0 to L length. So now we're going to find the half parabolic, the length, the half length. This means from here to here, 0 to L, 0 to 9. So since formula is half parabolic and our structure is full parabolic, so for the complete arch, we have to time by 2. So this 2 times by integration from 0 meter to 9 meter of our half arch. We know our m is 100x, and our y 16x, 18 minus x divided by 18 square dx. So take out the constant value. So we have 3200 divide 18 power of 2, 0, 9. So we left x square minus x power of 3 dx. So you have to integrate that and become 18 power of 3 divided 3 x power of 4 divided by 4 in between 0 to 9 meter. So we're going to have value for integration my dx between 0 to L, 27,000 kilonewton meter cube. So we have this value. Now we need to find value of integration y square. So we know our y is here. So we need to get value for y square. 16 power of 2. So x square. This one become 18 x power of 2. So 18 power of 4. for y power of 2. Now we need to find integration of y square dx. So for this one, we're going to take complete parabolic between 0 to 18 because the equation is only on y, don't have m into this equation. So 16 square, 18 square, 18 minus x power of 2 divide 18 power of 4 dx. Take out the constant value. You have to expand this. So in between 0 to 18 meter. So we get the answer for integration y square 153.6 m cubed. So this value for integration between 0 to L y square dx. So we have that value, so we can find what is our h. And formula for our h, integration 0 to L my dx divide integration 0 to L y square dx. So we have this one 27,000, this one is 153.6. So we get our horizontal reaction 175.7 kilonewton. So this is the answer for H.